What I'm going to talk about in this talk. First, I'm going to give a brief overview of what is in COM+ versus what has been in MTS, what is new, what is changed. And then we're going to try to apply some of these features to certain scenarios, development scenarios, what can you reconfigure applications, actual configuration scenarios, sort of pre-deployment when you get your application ready for a specific environment. Then we're going to talk about deployment mechanisms, how to get the actual bits into place where they're supposed to be, and how to keep them updated in different scenarios. And we're going to talk about keeping the hand on the pulse of the application using monitoring and the instrumentation we have, and that's where Scott is going to come in. And in the end, we're going to talk a little bit about some internals like RegDB and address questions. Please, if you have questions during the talk or now, send them to this email account that's on the bottom of the slides, count99@microsoft.com. We will be able to answer some of these questions in the end. Let's get started. An overview of MTS administrative features versus those features in COM+ 1.0. So MTS had an MMC snap-in called the MTS Explorer. In COM+, it's now called the Component Services Snap-in. Similar functionality. We're still using MMC here, so you can integrate these with other consoles and other administrative tools. The administrative interfaces used to be called MTS Admin. In COM+, they're called COM Admin. Similar philosophy, of course, new functionality available, but other than that, building on the success of MTS here. What used to be called a package in MTS is now called an application. In part, the reason for this is that we envision the paradigm we're using for COM+ applications to be carried forward in the future and be expanded to cover more than just components, to cover other kinds of elements of applications. What used to be called .pack files are now .msi files because we're integrating with a platform with a Windows installer on this platform. Functionality is still available, of course, of these files. For DCOM client, in MTS we used to have the client export feature which generated client.exe, a self-extracting executable. In COM+ we call these application proxies, and they are actually full COM+ applications. They have MSI files, they can be installed, uninstalled, they appear in the UI, etc. The replication utility, MTS REPL, is now called COM REPL, and it has more features. Instrumentation has been greatly expanded. We'll elaborate in more detail on this later. And the corresponding SDK utility is now called the COM-SPY. Certain things have been removed from COM+ 1.0, from the admin interfaces, just because the features are different now. Remote components, the collection is not there anymore. Replication share is not needed anymore because replication utility takes care of it automatically. And the application install path has been deprecated, is actually not supported anymore because we're integrating with the Windows installer. So, what's new in COM+ versus MTS? Of course, there's support for all the new COM+ features, including QC. One can turn on and off the listener. There's application proxies for Qt components as well. So if you have a client that remotely wants to access a server via Qt components, that can be done just as easily as it can be done with DCOM. Method level security has been added, sort of an administrative feature as well. COM+ events can be administered through the admin interfaces and is part of application export and import. The CRM, 3 GB support for x86 machines and other machines. These are attributes that are not exposed. And there are also machine level attributes that do not get exported, but they do get replicated. Most of them get replicated. IMDb is one of these machine level features. DCOM settings, and we have component load balancing as well. That's a machine-wide setting primarily. In the admin area itself, there are certain core features that just make administration easier across the board, regardless of what features you're using. The first one is the Windows installer integration. This just gives us a more robust setup, and another side effect is that we can deploy these applications and application proxies through the IntelliMirror feature in Windows 2000. Application proxies have been greatly enhanced. It's easier. We're going to talk about them in a little more detail further down. Talk about ComRepl being simplified. No need to create network shares anymore. It all just happens automatically. Administrative operations are now transactional. So when I install an application or multiple applications, either all of those get installed or none of them get installed. In addition, these transactions can be composed. This is something that is not in Beta 3, but will be in the final product. That means I can do multiple operations under the protection of a transaction, even coordinate this across multiple machines, and DTC will take care, will ensure that all these installations, all these changes, either all happen or none of them happens. This is a great feature. We're going to talk a little about that further down. The new feature we have is the constructor string. It's a tiny little string in the UI, also available through the admin interfaces. And it's sort of a general purpose environment variable that you can set for each component. One application for it is maybe to configure DSNs for databases or any other configuration settings. It's not very formalized at this point. It's really just a string, but it could turn to be very useful in your application design. We have extensively instrumented the runtime MTS. We had the MTS events with MTS Spy, but we have greatly extended that. Let's leave it at that. It's much more robust implementation, and we're using COM+ events, so we tie in into the infrastructure that's going to be built and is being built around these COM+ events. We've improved debugging both for VB and VC components. There's certain for VC there's an attribute in there, the debugger command line, if you've seen that in the UI. So you basically just turn a flag on, and the next time the application gets activated, it comes up in the debugger. Used to be a little tedious in MTS. And the last feature is we call this the self-describing components. Those are components that do not have DLL register server entry points anymore. This feature is sort of there, but unfortunately there will not be any tool support anytime soon. This will have to wait until VS7. Nonetheless, this is something that's coming sooner or later. So after this feature list, let's see how these features might be applied in certain scenarios. And let's start with application lifecycle, maybe not the beginning, but pretty close to the beginning. We're developing an application, so we need to create a COM+ application now and add the components, the classes, to this application. So we install these DLLs. I should not import them because we're really trying to move towards this installation model where COM+ really owns the installation of this component. If you just pick individual classes, then the deployment features, export features, etc. do not really work very robustly. Once the components are added, attributes need to be specified unless they're compiled into the component. Currently only the transaction attributes can be specified in VB6, for example, or in other languages. With self-describing components, more attributes will be specifiable. Today, in most cases, these attributes have to be specified after the component creation time. And these can be specified through the admin interfaces or through the UI. Then there's other attributes that are not a good thing for being compiled into the component because they are going to be more dynamic depending on the application that they're being used in. These attributes like roles.
Can I just update one thing? You can continue to talk to this.
We just have an out of sync problem here.
Yeah, so just kind of continue to talk.
So roles are attributes that are not necessarily compiled into the component. They could be compiled in, but in some situations they are modified after the fact. And there's other attributes that are sort of specific, like object pooling, load balancing, and QC requirements that can be specified at an application level, but are not really component level attributes. Once all these attributes are specified for the application and for the components, the typical case will be that you export this application into a Windows installer file, just like you did in MTS, exporting it into a pack file. And in COM+, you obtain a single installation file rather than in MTS, where you had a pack file with a bunch of files and DLLs that were just loosely lying around. So at this point, development is finished. We have a single file that we can then hand over to whoever is going to do the configuration of the application. Configuration. Under configuration, I mean understand the adaptation of the application to a specific environment. So administrators are going to be doing that, or maybe even customers. To do this, oftentimes the application will just be installed. The application that the developer created is installed onto the machine, and then the environment-specific details like role membership, user accounts, user groups, etc. are filled in. The specific server names, application proxies are created at this time. The application cluster is set up, the members of the machines, which machine is the router, and all these other attributes. And once this is done again, the export feature should be used to export this fully configured application, and also the application proxies if the application requires DCOM or QC. Now, in many cases, an application is installed multiple times, not just once. Right? If you think of a bank with 500 branches, each branch will want to have its own security configuration, etc. Even though it's the same code that is running, the application settings are different. So a good thing to do is to use the COM administrative interfaces to automate that. So rather than doing it in the UI one by one manually, you write a script, maybe drive the script even of a database or some other repository of information, and you end up with all these installable COM+ applications. All these configuration and deployment can also be done remotely, point to point, so I can connect from this machine to another machine somewhere else and do all these changes remotely, so that's an important thing. And let's drill down a little bit into the administrative interfaces. For those of you familiar with MTS admin, these are very similar in philosophy and even in name. So we have three fundamental objects here with their corresponding interface. First one is the COM admin catalog interface, the root object that starts the object hierarchy, basically, the object model. And it has methods like connect, where it can connect to a remote machine. It has all the actions at the application level, like installing and deleting an application. It's installing and exporting applications. Deletion happens in a different way. Components are installed through the utility interfaces, and certain actions like starting and stopping machine-wide resources like IMDb are here. And then probably one of the most important methods here is the get collection method that lets you navigate then the object hierarchy, the data hierarchy. So all the folders that you see in the UI, like the application folder, the component folder, the methods folder, etc., map to collections in the administrative interfaces, and these collections can then be navigated. So I do a get collection for the applications and enumerate in there. And then I get a collection object, a collection interface, where I can then add and remove and do changes to these items in the collection. And each item in the collection is again characterized by another object that basically has a key name-value pair that can be used to modify these. So next is going to be a little example of a script that configures an application with a specific NT user account, giving a fixed set of roles. So the steps needed to do that is first I will want to install my master application, the application that the developer handed over to me. So first thing is I create the root catalog object. This is a VBS script basically. So I have this interface pointer, and now I install the application that I want to install by pointing it to the MSI file that the developer gave to me, and I install it into a temporary directory on this machine. There's actually a typo in here. I just noticed this catalog should be CAT, should be the cat variable that I created up there. Apologize for that. So in the next step, I'll find the application in the collection of applications that are installed on these machines. So I will call the getCollection method on my root catalog object. I will read the data. This time in a single round trip, I would go to a different machine if this were cross-machine, and get all the information over into this collection. And now I start just enumerating these applications in there until I find an application that has the name that I'm looking for. If I find this application, I navigate to the roles collection under this application by calling the getCollection method again on this collection object. And I get a sub-collection now, and I assign this to this roles variable in this VB script here. And then I populate this collection again, and this time I would go over to the other machine, or I go to the catalog server, and I read all this information into this collection. And then I just finish this loop. So now the next step, now we have this roles pointer here, this roles object variable that points to the collection, the roles collection that we want to modify. So the next step, we're going to add a user to this role. So the developer gave us this application with just a role definition, no members in there, because the developer didn't anticipate what exactly this application was going to be installed into. So the next step, we're going to get the users collection, the users and role collection for this role object, for this particular role. We're going to find the users that the collection that has the users, and we're going to read the users, and now we're going to start adding a new user to this collection that has the users for this role. Once we have this user object here, now we're talking through the icom-admin catalog object. We're going to change the value of this user to be the specific user account. In this case, domain is branch, and the user group is Traders Mexico. We save these changes, and we're basically done. Now we're exporting the resulting application to a network share, so we can then deploy it to the production machine. So this was briefly illustrating the use of the administrative interfaces for creating configured applications. Now we have these 500 applications sitting around there, and they are ready to be deployed to these branches. So the next feature that we're going to apply there is the deployment feature that uses the IntelliMirror feature in Windows 2000. And here we're going to use basically central management in the directory service by adding these applications and assigning them and publishing them to specific users in our domain. And we're going to use the group policy object that can be associated with an OU to do this. There's actually information about this available on our website. If you go to http:/com, there's a detailed walkthrough if you're interested. There will be a reference on this later in the slide deck. So there's different mechanisms to deploy these applications. The first is these can be deployed to user accounts. So I know there's a certain group of users in my organization that need to have access to this application. So I will assign this application to them, and there's two mechanisms that the IntelliMirror feature offers. One is what is called the assign mechanism. I can assign this application to users. What this means basically is as the user logs on, the system will perform a minimal install of this application. We'll basically do a little pre-registration, register the file extension, etc., so that as the application is being used, and also install shortcuts, etc., so as the application is being used, the actual bits will get installed, but the application appears installed to the user. The second mechanism here is to publish this application. This is basically just making the application available to the user so that it can be installed on demand. And this demand can be either via the add remove programs dialog, or by clicking on a Word document and then or document and file extension association. But also, and more interesting to the topic of our talk, is that COM activation also can trigger these installations. The co-create instance has been changed. There's a new flag that you can specify new class context. It actually enables directory service lookups. So you need to specify this flag as class context underscore enable code download, basically. If this flag is specified, then COM will go to the directory service in the case of a failure of a lookup. So if a class is not registered in the registry, COM will go and clear the DS and download an application if necessary. The equivalent API for the class ID from prog ID is there's not a flag there, so we introduced a new API. It's called class ID from prog ID EX. This API is actually being called by the VB6 runtime. So if you have VB6 generate applications, these leverage the class programmatically. Now, if this flag is not specified, in other words for existing applications, for legacy client applications, VB5 for example, but also Office and pretty much all these other COM applications in the world, these do not get automatic directory service download, and that has been done for several reasons. There's performance reasons there, because applications rely on the behavior of co-create instance failure. Not always do we want to go across the network. There's certain other issues there as well. Now there's a flag that allows you to enable this, but it should be used with care, because co-create instance used so broadly that the effects of this flag could be pretty hard. So this should be tested and used only in very limited scenarios where you know exactly what the set of applications on the desktop machines is going to be. So we have assignment, installation at logon time, we have publishing, on-demand installation, which can be triggered even by co-create instance installs. These applications, once they're on the machine, get updated at logon time only. This is a design decision that has been made because it is hard to determine if an application is running, and the user experience is probably not too pleasant. If I'm using Word right now and somebody decides that I should now be using Word 2000 and this application gets automatically updated for me while I'm using it, it's not a nice thing, so the decision has just been taken to do this at logon time only. The second way to use the IntelliMirror feature is to deploy actually to machines. Rather than associating these applications with user accounts, they get associated with machine accounts and are then available to all users that happen to be the victims of logging onto these machines, if there are any. But the main application for this feature is basically to deploy to servers where potentially nobody is ever going to log on to anyway. And for machine deployment, the only available option is assignment. So there's no on-demand installation. It doesn't make too much sense anyway. So at boot time, the applications are basically looked up in the DS and installed, and fully installed. It's not an incremental install happening here. It's a full install, so when the machine boots, it takes a while, and after all these installations have happened, the machine is in a state and it's ready to go. So there's certain problems with this. One is obviously the limitation that updates only happen at logon or at boot time is a problem in some scenarios. In general, it's a hard problem to solve, but in some scenarios it might actually be very feasible, especially in server applications where you know that you can robustly shut down, for example, a COM+ application. There's features for that, so I can actually update this and not have to worry about the files that are being used, etc. So one workaround that customers can do is to actually trigger these updates programmatically. There's APIs for that, IntelliMirror APIs, application management APIs. And those could be called from a script that could be run periodically, or there's actually a policy refresh happening, and that can be hooked to run scripts. So this is one potential workaround to update a certain set of applications that are known to be safe to be updated at times other than logon or boot time. Another problem that you might encounter is more for server application deployment, and that is has not been well addressed for MTS applications either, and this is managing the identity for server applications. So if a server application needs to access resources, network resources, for example, database, etc., you want to be able to secure these resources and only allow the application access to these resources. The problem with this is that you need to manage the passwords, because the machines that use this identity need to know the password in order to be able to log on and to get authenticated. So one idea for a workaround in this problem, is, well, first, today the only option you have basically is to install the application and then go in through the administrative interfaces and the UI and manually establish this password. We do not export the password. We do not provide this option because it's considered a security problem to have clear text passwords stored in files. So when deploying using IntelliMer, the whole idea is to do all this centrally in the DS and not having to touch all these machines individually. So one workaround is basically to reset this password at the time that the application is installed. This could be done in a script, a logon script, or it could be done in a Darwin custom action. The Windows installer is extensible and can run arbitrary code by adding custom actions to these Windows installer files. So as this application gets deployed to the machine, the system would go in and reset the password to a new random value. Sorry, not the system. The script would go in and reset the password to a new random value, and that would then be used and would then be stored in the COM+ catalog using the COM administrative interfaces. This works relatively well for local accounts. It can also be used for domain accounts, and this is something that's enabled by the Windows 2000 Active Directory, in that machine accounts can now be granted access to network resources. And what that means is that any code that is running as local system on these machines then has the permission to access these resources that the machine account has been granted access to. So this trick can be used to actually have domain accounts that are centrally managed, and it requires an account for each application and each machine, because we're going to be resetting the password whenever this application hits a specific machine. These accounts could then be added to user groups, so that the hackers do not have one of these, many of these accounts available, but instead a single group. And then, as I said, you can grant the local system account, the machine account, reset password privilege, and change these passwords. So this is probably a little complicated. There's more information again available on http:/com in case you're interested. So we talked a lot about the IntelliMer feature. Here's a slide illustrating how this could be applied in practice. So we have a user that's logging onto a laptop, to desktop. Windows goes out and authenticates the user against the Active Directory. At the same time, Windows also goes out and determines the list of applications that should be available to this user, that should be assigned on this machine. And these applications get pre-installed, automatically downloaded and pre-installed on this machine. Now, servers boot, maybe they booted before the user logged on, potentially. And at boot time, again, the system goes to the directory service and determines the list of applications that should be assigned to the server. So in this case, the COM+ server applications could be downloaded and installed on this machine. Now, as the user starts running the client application, it tries to connect to the server. So it does a Cochlear instance request, and it does not find the proxy, the application proxy for the server application. So COM goes to the directory service and looks for an implementation of this class that is available to this user. So in this case, we find the application proxy in the DS. It was published to this user, and download this application proxy. I just noticed that this is a fairly complex build slide, so I apologize for this. You might want to be able to go to a network share or to the COM website to find this slide in a more legible version, so I'll just skip over this. The basic idea was that as more people start using this, the applications just get automatically installed on demand. So we talked about using IntelliMirror, the directory service, to deploy applications from a central location. Another common scenario is actually one where I have multiple machines that are used as a cluster for load balancing, or as in a web farm, or a failover cluster. And these machines have to be maintained and have to be running the same set of applications, they have to be identically configured. So I have a replication problem. I have this set of applications and settings that exist on one machine, on a master machine, and I want these other machines to look just like this other machine. And COM+ offers a utility for that. Actually, it's the command line program. It's called comrepl.exe. It's installed into the system32 directory. And the way you use it is you basically just type this, and you give it the target machine to which you want to replicate the application on the machine that you're running this utility from. This utility will just go in and copy all the apps by exporting them, copying all the machine settings, and connecting to the remote machine using the COM administrative interfaces, and installing these applications onto the target machine. It actually deletes all the applications on the target machine before it starts copying anything. So this is really mainly intended to be used for master and identical duplicates, identical replicas of these machines. When used with web farms, IIS offers a similar utility. It's called the IIS sync utility that replicates the metabase settings. And this utility actually invokes the comrepl utility as well, so that the IIS applications also get replicated along with it. This utility is already available in MPS today, but it has been simplified. You don't need to create these network shares anymore. All this happens automatically under the covers. Now this is a list of problems that I heard from the questions that came in. I'm trying to answer these here. So first problem is hot update of applications. So I have this application production and I now need to update, but I can't afford any downtime. So if you have a load balancing cluster or a web farm, it's actually possible to do hot update by just simply replicating to these machines one at a time. The machine being replicated, of course, gets taken out of the cluster either automatically, depending how the load balancing engine, how resilient it is, or explicitly by taking the machine outside of the cluster for a certain for the replication period. And while this machine is down, all the other machines, of course, continue to work. It gets updated using the replication utility. When it's done, it gets added back to the cluster, and things are fine. And then I can go one by one through each of the machines. And when I'm done, all my applications are updated without any downtime, assuming I did the proper testing, of course, of the new application. Now, there's a certain set of updates that cannot be done this way because maybe the database schema changed for the new version of one of the components. So I cannot really have both of these versions running at the same time in this cluster. So here's an idea for a trick to deal with this. It's basically take 50% of the machines, or any number of machines, take them offline, update them, and once they're updated, until they're updated, we leave the old shared resource, the old database schema running. We leave that in place. And now we do a quick switch over. Either we have another database server and we copy the data over, or we just do the schema update with a migration of the data. This is the critical part because this shared resource by nature has to be down. It cannot be running during the upgrade. And once this shared resource is upgraded, we basically take the new machines, the half of the machines that we have already updated, we bring them online again, and the application continues to run. At this point, we can then upgrade the remaining machines that we took offline in the beginning. So this is a technique that can be used to minimize the downtime when it's unavoidable that there has to be downtime. because the shared resources has to be updated. Well, now let's talk a little bit about distributed application, where I have either two servers talking to each other or a client talking to a server, desktop talking to a server via DCOM or via QC. So the problem here is basically we need to get type libraries and proxy stubs for the interface information onto the machine, and we need to get a class registration onto the machine that allows COM to find the server, basically to know the remote server name that I'm going to talk to. By MTS, this functionality was provided using the client executable that was just automatically generated whenever you exported a server application. In COM+, there's actually an option that lets you choose what kind of export you want, the server application or an application proxy. And the result, when you export an application proxy, is an MSI file that can be used with the Windows installer. It can be run from the command line, just like the client executable. You can right-click on it in the shell, and it'll give you a bunch of options there in the context menu. It can be installed via a batch file, of course, and it can also be deployed via the IntelliMirror feature. One nice feature is also that a different server name than the one that has been burned into the application proxy at export time, a different RSN, a different remote server name, can be specified when installing this file as a command line option. And we also show application proxies in the UI, so they're a first-class citizen of the COM+ administrative world. So in the UI, it's also possible to change the remote server name after deployment. So if a server has changed, it's possible to go in through the UI or through the administrative interfaces and redirect these clients to talk to different servers without reinstalling the application proxy. Some implementation notes here that might be interesting, especially for troubleshooting. On Windows 2000, when we install an application proxy, there are no registry keys written anywhere. All the class registration happens in the registration database. We talk about this later. So there's no registry footprint, and COM activation takes this activation information out of the COM+ catalog, out of the COM+ registration database. Interface registration still happens, though in the registry. Type libraries, proxy stubs. This is mainly for legacy reasons. On Windows 95, on the 94, the Windows installer has to be present in order to install this Windows installer file, obviously. So that's a little caveat here. It's not sufficient to just run the client executable anymore. The Windows installer has to be pre-installed. The good news is Office 2000 ships the Windows installer, so it should be pretty common on many desktops relatively soon. As I said, application proxies can be deployed via IntelliMirror, can be assigned, can be published. So this gives a unique mechanism to update server locations, for example, using directory. Little caveat is users have to log off before they get the changes, but it's probably better than having them browse to certain pages and they're out of date and they get weird error messages. Now, application proxies are their own standalone MSI files, Windows installer files. They can be kept like that separately, which has certain advantages because the actual client application, the client executable, for example, still remains intact even if I change my server location, for example. I don't have to reinstall it. Right? The 401k VB client exe doesn't have to be reinstalled with all the other state that it incurs. I only update the application proxy. But of course the application proxy can also be merged in for situations where that's desirable, where the server doesn't change that often, or where it's just a question of convenience. And application proxies can be deployed via internet code download, just like the client executable. Object tag, the code base can point to this application proxy, and when you browse to this to the page, the application proxy is automatically installed. It's a little caveat: the MSI file, the raw MSI file, cannot be used directly. It has to be first wrapped into a CAD file. In Beta 3, that has to be done manually still, in the final version of Windows 2000, we will automatically generate both an MSI file and an MSI file wrapped into a cap file that can be used directly. And of course, if you care about authenticate and authenticode, which in most cases is necessary, the cap still needs to be signed with a valid certificate before the download can actually happen. So here, in Beta 3, things are a little more tedious than they were in MTS, but that will be fixed in the final product. So, now we're going to talk about, so now we have deployed these applications using different mechanisms, entire mirror, code download, manual installation, etc. Now we want to monitor this application, and the feature we have in COM+ there is, of course, we have in the UI rudimentary monitoring that gives you certain component statistics. But we have way more information available that we have provided by instrumenting the COM+ infrastructure itself. So there's more than 80 different events like transaction aborted, committed, method call enter, method call leave, etc. Very, very granular information that's being provided, and that can be seen using an SDK tool, ComSpy. It's possible to write monitoring applications that target this, application-specific or generic. And actually today I'm glad we have Scott here, who is working for ExtremeSoft. He's going to talk about how ExtremeSoft is using this instrumentation to provide monitoring capabilities.
Thanks, Markus. So we instrumented, as Markus said, over 80 different unique events. These are as granular as a method call. They cover things like load balancing, activity creation, deletion, and many different areas. The ComSpy utility that is part of the SDK shows you how to do that, and it's an implementation that's based on the MTS Spy utility. In MTS it used connection points to get the information from MTS to the user's program. Now we use the COM+ events. So actually here, so my name is Scott Matsumoto, and I'm the CEO and the CTO of ExtremeSoft. We're working very closely with Microsoft. We have been for the last 6 to 8 months to provide monitoring tools for both MTS and COM+ applications. Our first product right now is available now. It's a set of perfmon extensions to bring you the same information that you can get from the MTS Explorer through perfmon, as well as being able to monitor all the various system metrics about each package server. So we have component statistics, we have package statistics, and we also let you find the system process information, but rather than figure out which mtx.exe process it is, we let you pick it by the package name. And we've done that for MTS, and we have ported it for COM+ as well. And this shows you just a perfmon display with some of the different counters that we have available now. So here we say we will be coming out with a COM+ version that will run with Beta 3 within the next 2 months, and you can get that from our extremesoft.com site.
And that site again?
Oh, I'm sorry, is www.extremesoft.com.
Okay, because they're.
Oh, I'm sorry.
I can't see this.
You can't see it? I'm sorry. Okay.
Are these slides going to be available on your site also?
We will make these slides available on the site. That's
excellent.
A great idea.
Great.
Well, perfmon is great. It's a nice tool for when you can sit there and look at your application, but when you actually have deployed an application, there isn't usually someone to sit and watch it. But a large enterprise is going to need more than just perfmon to monitor their application. So what we've built is a product called Cometer, and that Cometer product takes the instrumentation that we put into COM+ and as well at MTS, and creates a whole monitoring platform. So the idea is that we, just as COM+ builds an application view of the application, we build an application view of the performance. We believe that you automate the performance monitoring so that you can deploy your application, deploy the monitoring, and then be notified when things go wrong. And we then, so in essence, what Commenter does is it ties the information from the ComSpy interfaces into WMI. So you can see, I don't know if you can see, can they see? Oh, they can't
We're
see.
switching back and forth between your image and the slides in here.
Okay.
So
if we can switch back to this picture,
great.
great.
It's a little delayed, so.
That's fine. But that's perfect. What this shows is we gather up all the information from the ComSpy interfaces that's been emitted by the Com+ runtime system. We gather it in our event monitor. We collect and log the data in a data warehouse in a SQL Server 7 database. We then have a set of reporting tools, what we call a portal site in your enterprise, where you can go get information about the performance data of your Com+ applications. We also hook into Exchange for delivering email notifications, pager notifications. We can deliver then more events up through WMI, which then can take you to your enterprise tools like Tivoli and CA, and you can browse the information through a browser like Internet Explorer. So it's a monitoring platform. We gather the information. The information that comes out of the Com+ runtime can be very granular. It can be as granular as a method call. And for monitoring a deployed application, it's more important to aggregate that information because you might have thousands or tens of thousands of method calls happening in your application. So we aggregate the information from multiple different sources too. So we will bring in information from the system and correlate it against your application performance. We create new events through these by correlating this information together, and those are the things that we then republish through WMI. And all of these events that come in through us, those that come in, the raw events that come in from the Com+ runtime, those that we create by aggregating information, all those events are scriptable using VBScript or any other ActiveX scripting language. And then, one of the outputs of what we do is we collect the information and then present different views of the application. What we have here, what I'm showing here, is just one graphical view of the response time. What we're measuring here is activity response time. These are Com+ activities, creations and deletions, relative, and how many are happening, how many have happened in a particular time interval. We measure them in various, we have what we call a short interval. And the short interval says it might be, say, 10 seconds, and then we aggregate and average them over the longer intervals, which might be a minute. And then we keep all that information, and you can go back through the data warehouse and do analysis based on historic information of the various system metrics. So our Proof1 for MTS products is now shipping. The Commenter is in beta. For the Commenter for MTS will happen the beta will happen in May. We have Commenter for MTS V1 will ship in July. Perfmon for Com+ is going to be available concurrent with Windows 2000, and Commenter for Com+ will be shipping in January of 2000. That's assuming ship date of Windows 2000 in around the December timeframe.
We all assume that.
So, if you want to get more information, there's information about all these products on our website, which is www.extremesoft.com. You can contact me through extremesoft.com, scott.m@extremesoft.com, or for sales, Steve W. at extremesoft.com.
If you have any questions you would like to ask Scott right now regarding Perfmon, please send them to count99@microsoft.com. And we will try to address it before the end of the session.
I'm done. Thanks, Marcus. Back to you.
Okay. Okay, now coming to the more question-oriented part of the presentation. So there was one question about, or many questions actually, about what the COM+ registration database is. So I'm going to have a little summary here of what it's all about. First of all, it's a store, it's a separate store that captures all the application and class attributes, like transaction attributes, the roles, if queuing is enabled or is not turned on, the queue names for the application, etc. All these additional attributes that are COM+ specific are stored in this database, and the physical files for this database are in the Windows directory. There's a registration subdirectory under there. And if you open this now on your machines, hopefully all of you are running Windows 2000 at this point, you will actually see several files there that end in the .clb file extension. And these files get actually updated when there's a change. We basically copy the entire file over, give it a new number, a new name, and make that the new file. And as other processes stop using the old versions of the file, these files get deleted and aged out. We always keep 2 copies around just for resilience. The store is actually transactional because we do careful replacement, and we're also using the CRM, the Compositing Resource Manager, to tie all this into the DTC transactions. So this is the way how we make COM administrative transactions also composable and distributed. So we can install applications and change settings, etc. Under transaction protection. It's a very useful feature across machines especially. But there's some limits to the transaction. This transaction is really only for the RegDB store. So any attribute that is not stored in the store, anything that modifies something that's outside of the store, is not necessarily transactional. So if you install an application that has a component that requires COM registration, DLL register server, etc., modifies the registry, that part of it is not transactional. So the registry could still be in a weird state at that point. Same for changes to MSMQ, for example. Install a queued application that creates a queue. These changes are not 100% transactional. Changes to the file system are done by actually the Windows installer, so they don't necessarily tie into the COM+ transaction. Darwin has their own transaction system, but that one is not composable. So if you know what you're doing, if you know which attributes you're choosing, you can really use this to have distributed transactionality of administration. So we talked about COM components being in the registry, and that is definitely the case. So when we activate, we get some of the attributes from the registry, like the threading model, class ID, the inproc server 32 location, etc. And all the new attributes, the additional attributes, transaction required, etc., those come out of RegDB. So the system has this catalog server infrastructure that does a join, that does the logical merge of these things, and presents that as a single view to the runtime, like OLE32 and the COM services runtime. The RegDB store is completely closed. We did not want to expose it like happened with the registry, because that causes lots of problems today, where we cannot really rove the store because applications have developed dependencies on the specific store. That's why we chose to only allow access to the RegDB store through the COM admin interfaces. So this is the gist about RegDB. And here's some other questions that I hope were already answered in the presentation. Class store is definitely still there. It's the part of IntelliMirror where co-create instance and class ID from ProgIDEX trigger download of applications. The backing store in the DS is the class store. COM versus MTS admin, covered that in the beginning. Everything is accessible programmatically, definitely. We covered RegDB. And we also talked about some issues in around deployment. And the recommendation here really is to not deploy at the component level, but deploy at the application level. Things are really much more robust in that case. You get great mechanisms, IntelliMirror, remote administration through the COM admin, replication, etc. So it's really better to not micromanage at the component level.